Hello, welcome to my lecture application of psychoacoustics in product development. I am Ercan Altinsoy, Chair of Acoustic and Haptic Engineering, Technische Universität Dresden. I will start today with a short introduction. After that, I will introduce some applications, for example, product sound quality, noise abatement, also noise emission, traffic noise, binaural models for room acoustics and also electroacoustics. After that, I will talk on evaluation methodologies, psychophysical measurement methods. They are very important for such kind of applications and the evaluation. At the end, I will talk on the knowledge of multimodal interaction. The meaning of sounds for us is very high. In our daily life, they deliver us a lot of information about environment, also our interaction with objects, also with products. Therefore, we take into account our auditory sense in daily life very much. And in this case, we try to build a bridge between physics and perception. If we can build a bridge with our physical knowledge and perception, it can be very helpful for different applications. But of course, the relationship between the physics and perception is very complex. In that case, psychoacoustical parameters can help us for applications and characterization purposes, for example, loudness, sharpness, tonality. If we talk about the application areas, we will notice that there are a lot of different applications of psychoacoustics. First of all, of course, sound quality, sound design, also noise abatement and evaluation of noise emissions. Also for telecommunication, it is very important, speech-related aspects, applications. Also audiology, hearing aids, and audio reproduction systems or room acoustics. Today, I will concentrate on three aspects: sound quality, sound design, also for noise abatement and evaluation of noise emissions. If you look at the industrial applications, you can see in this slide some typical applications. For example, vehicle industry has great interest for psychoacoustics because you can use psychoacoustics to describe the perception of vehicle indoor or outdoor sound. Of course, household appliances also very relevant. In that case, again, play very much role to characterize the pleasantness of the sounds, but also annoyance, also brand design and sound design. We use psychoacoustics also for description of quality of concert halls and room acoustics. Also, other application area is noise abatement or traffic noise. It is very important to describe our annoyance regarding such kind of noises. And at the same time, we use, of course, psychoacoustics for coding, like MP3. Also for hearing aids, it is quite important. We have different psychoacoustical parameters. In the lecture of psychoacoustics, you learned some of them. For example, we have loudness. It describes how loud we perceive the sounds. It is very different from the sound pressure level. It describes the perception. At the same time, we are very sensitive to the high frequency content of sounds, and sharpness describes such kind of aspects. Also, we are sensitive to the temporal change of the sound, and in that case, modulation elicits two different perceptual attributes, roughness and fluctuation strength. Therefore, they describe the modulation perception. Also, we are sensitive to the tonal components, and therefore we need the tonality. And if we talk about impulsive short sounds or also complex product sounds with impulsive elements, in that case, impulsiveness is very useful to describe such kind of perceptions. Also, we have already some standards for psychoacoustical parameters. In that case, for loudness, in the slide, we see that there are some ISO standards, but also German DIN standards. and also American standards. In that case, we try to calculate the loudness. And also for in-stationary sounds, non-stationary sounds, we have some standards to use, also for steady sounds. In that case, also there are some standard graphs for loudness, for example, for Zwicker method and also Moore and Glasberg method. For sharpness, there is a German standard. Also for tonality, there is a German and also American standards. If we start to talk about product sound quality, of course, in that case, industry has aim to produce high quality products. At the same time, of course, sounds give hints about the quality of these products, and therefore it is very important to evoke high quality product association. Therefore, in that case, product sound is a hint for us for the product sound quality. And in that case, of course, perceptual evaluation is very important, which I will talk today. And we need some measures to describe our perceptual evaluation, our perception. And in that case, as I already said, that sound pressure level is not enough to describe it, because same products or different products can have same sound pressure level, but in that case, they can evoke very different sound quality impression. Of course, the first step, we can apply our frequency sensitivity and use decibel A. It is the first step and it is helpful, but it is also not enough to characterize these aspects. In that case, we need some other psychoacoustical properties. Of course, at the same time, if we look the definition of the product sound quality, we notice that it is very much context dependent, and it is dependent on our expectations to the sound and also our test. Therefore, we should take into account this context dependence and also our expectations if we evaluate product sound quality. Therefore, in this slide, I try to summarize the procedure for product sound quality research. In that case, our aim is to develop a statistical model or index to describe the product sound quality. It will help us for the product development. And therefore, of course, we should start first of all with recording of the product sound. And if we make some recordings of different products, at the end, we would like to know that how we perceive these sounds. Therefore, we need some evaluation experiments, listening experiments. And at the same time, of course, the analysis of the sounds using some signal analysis and also psychoacoustical analysis is quite important. And at the end, we try to correlate the results of the evaluation experiment and also signal and psychoacoustical analysis to develop such kind of indexes or statistical models. In that case, we use, of course, linear regression or multiple linear regression, and it is very helpful to describe good indexes. In another lecture, product sound design, I also introduce car door sounds, for example, is very important for us. If we want to buy a car, first of all, we, of course, meet with car door sounds. And in that case, we have two different aspects, two different information, which are very important for us. First of all, high quality, and at the same time, security. It means that we would like to be sure that the car is closed. And in that case, we have, of course, different car door sounds. Like first example, I would like to play it. Or second one, maybe again, first, second one, then third one, or fourth one. You notice that there are different quality impressions depending on the sound. If we compare, for example, the sound of car A or car C. In that case, it helps us to check the psychoacoustical analysis. For example, in this slide, we see the analysis of loudness over the time. In x-axis, we have time axis, and y-axis is the loudness. And we can easily notice that the first sound has very loud sound in comparison to other sounds. It plays very much role, of course, for the quality impression. In that case, we don't expect so high loudness. Also, if we look this slide, we see the sharpness and time relationship. In that case, x-axis is the time axis and y-axis is the sharpness. And again, we see that if we have very high frequency components, in that case, it evokes an impression that two metal objects hint together. Therefore, it is, of course, not so good for the quality impression. In that case, we expect not so many high frequency content of the sound. Therefore, also sharpness is quite important to describe the quality of car door sounds. And in this picture, we see again loudness analysis over the time. And we have much more information. In x-axis, we see the time, y-axis, the frequency. Therefore, we can see now also frequency components of the sounds. For example, at car A, we see, for example, at 2 kHz and higher frequencies, we have a lot of components or content inside of it. At the same time, we see, of course, loudness level with color. It means that, for example, yellow means very high loudness and dark colors means very low loudness. And we see also the decay time for different frequencies. And we can easily notice that, for example, car C, which evoked very high quality impression, has very long decay time at low frequencies. In that case, we have when information about, for example, huge indoor of the car. Therefore, if we want to develop a quality index for such kind of car door sounds, of course, it is useful to use these psychoacoustical properties in comparison to the sound pressure level. For example, we can use loudness, sharpness, also decay time. And in that case, very important aspect is that, of course, it is very impulsive sound. Therefore, 5 percentile loudness is much more better to describe sound quality of such kind of car door sounds. In that case, with 5 percentile, I mean that the loudness value which exceeds for only 5% of the time. Also for sharpness, we can use it. I have also another example in that case for product sound quality. For example, vacuum cleaner sound. There are different kind of products in the market for vacuum cleaners. And in that case, of course, they evoke also different annoyance. And I would like to play 3 different sounds of vacuum cleaners from the market. First of all, first signal. In that case, we see the FFT versus time analysis. X-axis is the time, y-axis is the frequency, and sound pressure level is coded as color. And first sound. Second sound. You can easily notice that there are some differences on the perception. And third sound. I think it is very easy to evaluate them regarding their sound quality or annoyance. And to make an intelligent noise abatement, of course, for us quite important to know that in whole spectrum, which components are very important and how we can reduce them. And in that case, of course, psychoacoustical properties help us again. For example, we can easily notice that tonality is a very important aspect. In the first example, I remove the tonal component at 560 Hz after 2 seconds. And it caused only very low sound pressure level change, only 0.3 decibel lower. But at the same time, the annoyance will be very different. We will hear now this sound. Maybe I play again. You can easily notice the difference. But also, in the second case, I remove the high frequency components, and also the impression is very different. It means that after 2.5 seconds, we don't have any more these high frequency components. In the sharpness case, and you can easily notice that sharpness has also very big influence on the quality perception. If we want to develop an index for the annoyance of vacuum cleaner sounds, in the first example, we noticed that the loudness plays very much role on the perception, and therefore we need the attribute parameter loudness. At the same time, of course, high frequency contents are quite important, therefore sharpness and also tonality. And I didn't give an example, but roughness is also very important for the annoyance perception. At the same time, articulation index is very important because the vacuum cleaner sound can mask the speech, and we cannot understand, for example, television or telephone call. Therefore, we need also articulation index in our index to characterize the perception of vacuum cleaner sound. In previous examples, we saw that we use some linear regressions to develop some indexes. Also, in recent development in this field is to use artificial neural networks. Artificial neural networks are used mostly in machine learning and cognitive science. Therefore, it is also very interesting for product sound quality. Of course, main advantage of such kind of ideas is that their capability of learning and also pattern recognition, they can recognize very complex patterns, which is relevant, of course, to our perception. And in that case, artificial neural networks try to model actually humans' central nervous system. Therefore, we have different dendrites and also cell bodies and axons, as you can see in the slides. And we should define always some input. And after that, we should define some weightings. And depending on these weightings, we can define also an output. We use such kind of networks, artificial neural networks, for different product sounds. For example, for shaver. Actually, the strategy is very similar as previous strategy. In this case, we make again recordings and make some subjective evaluations, but at the same time, we try to obtain psychoacoustical parameters, and at the end, we try to develop artificial neural networks which combine the knowledge from the subjective evaluations and at the same time, psychoacoustical parameters. And in that case, of course, we have some input layers, and therefore we should decide which psychoacoustical parameters are relevant for our product sound. At the same time, at the hidden layer, we have different functions and different weightings. They are very important. Of course, they have big influence on the output. At the same time, of course, we can try to train our artificial neural network using different sounds. These are some examples for product sound quality, but at the same time, psychoacoustics is very useful also to describe how we perceive the environment noises, for example, traffic noises or aircraft noises. In this slide, I try to summarize, for example, some research, some investigation from FASTL. They try to evaluate the aircraft noise, and in that case, we see in this picture the loudness levels over the time for different aircrafts. And these investigations show that actually loudness can be used to describe the perception of or noise emission of aircraft noise, and in that case also 5 percentile loudness. Also, we use psychoacoustical knowledge to describe the perception of traffic noise. In that case, the evaluation of vehicle noise is very important, and also A-weighted sound pressure level cannot help us, but mostly used actually. We use maximum sound pressure level, and at European Union project, quite STI, the researchers developed a metric using different psychoacoustical parameters. For example, relative approach. The aim of the relative approach is to detect signal change in time and frequency domain. At the same time, they used the 5 percentile loudness and 5 percentile sharpness to describe the perception of traffic noise. Also, we see the psychoacoustical mapping. It can be used, of course, which was developed in European Union project CT-H. Of course, except of product sound quality and noise emission, also we use psychoacoustic knowledge in audio reproduction and room acoustics. And in that case, binaural models are very helpful because binaural models help us actually to define, to describe our spatial perception. In that case, of course, we hear from left and right ear, and both ears deliver us different information. And of course, interaural time and level differences are quite important. Therefore, these binaural models try to model them, and we can use them to evaluate, for example, audio reproduction systems, for electroacoustic systems, but also for concert hall acoustics or lecture hall acoustics. And for that aim, we use in most cases such kind of pictures or also videos. For example, this investigation was conducted by Hess and Blauert, and they try to model our binaural hearing. And using such kind of videos, we can decide that how good and how bad the room acoustics or electroacoustical reproduction.